This is Lou W1QJ. We're going to be doing a series of videos here. As I mentioned earlier in the group, that I was going to take a pretty much stock SB200, and I'm going to take you through the whole procedure of grounding the grids. It's not as simple on an SB200 as it is on an SB220. SB220 has conventional cutoff bias and operating bias, and you're able to unground the grids with the chokes and the capacitors and put the grids directly to ground. But you can't do that with the SB200 because the biasing system is through the grids and not through the cathodes, like on the SB220. So the grids have to be above ground for this original system. So most of all these parts here are dealing with the grid bias. Here you got grid bias resistors. Here's your capacitor grounding the grid here and here. And some of these other parts here are for the ALC, which we're not going to use, so we're going to tear that all out. This is all going to go, and we're going to strip this down and start fresh with a grounded grid scenario. So that's over here, and then underneath. Here's underneath. You can see this has already had a power supply upgrade here, and here it's got a soft key. And here is the original double pole, double throw antenna relay. That's going to come out. All this is coming out here. All this stuff's coming out. All going bye-bye. And I'm going to start ripping it apart. And the next video that I do will show you how much I stripped out of here. I'm probably going to take out the SWR bridge. I mean, nobody really needs that. Everybody's got an SWR reading system in their radio. So if they want to know what their SWR is, they certainly don't need one in an amp. So I'm going to rip that out. And probably in going into video number 3, we're going to end up having to work on this switch because we have to move some wires around on this switch, and we have to do some work right down in there because we have to change the grid shunt. The grid shunt resistor, and I'll explain that later. But for right now, it's just a tear down. So this is video number 1 showing the original amplifier that we're starting with. I've already changed out the SO239 for the phono. And I'll come back and I'll upload another video with everything stripped out. So 7.3 for now. Okay, folks. Lou W1QJ back again with video number 2 of the grid grounding of the SB200 amplifier. I told you in the first video I'm going to tear things apart. And here we are in the back. You could see we tore all the grid biasing resistors out. And all to do with the ALC. We're not going to be using that. So all that was here is gone. I cleaned up all the holes on the pins to get ready to do the grid grounding back here. There really isn't going to be much back here except for tying the grids to ground. There's going to be more underneath. Here's the parts that I removed here. Here's this SWR sensor here. Here's the soft key. Here's the old relay. We won't be using that relay because we're going to be using the antenna relay to switch the bias. So we need another pole on the relay. We'll be using a different relay, still 110 volt relay, because we have the winding for that. And we will be adding a soft key. Now I could change this over to 12 volts, but that would require adding another 12 volt supply. I didn't want to do that. I'll just put in another 110 volt DC relay, and I'll put another soft key in. Here's the old power supply section here. I'll turn it over. Okay. And you can see all the wires are spread out of the way. As the relay is gone there, the power supply section is gone there. I've already put in a new strip because I'm gonna rebuild the power supply there. This is part of the AC side of the power supply, that resistor. So I'll work with that. I rewired the. I'm going to rewire this fan here. I want to clear this area up for other things over here, and I'll probably end up putting another relay over here somewhere. We'll see. So when I come back, I meant to say that I told you that I was taking out the SWR. This guy over here. But incorporated with that was the relative power output. I'll be building back another relative output circuit. I'll build that back in here, and I'll connect it into the switch here. So that you'll still have a relative power meter when I'm done. We'll restore that. So I'm going to get to work starting to build back here, and then I'll explain what I've done. I've ungrounded the center tap of the transformer, which was going to ground, and you can see I added a piece on there, and this will end up going over towards the relay when I'm done. So there we go, all stripped apart. And I'm going to start building back. And I'll do videos as I go along. Okay, that's it for now. Hello, folks. W1QJ back again. This is the project where we're grounding the grids. Directly grounding the grids in an SB200 directly to the chassis, unlike the original design where they're floated on capacitors. We started with an original SB200, pretty much factory stock, except for the fact that we've already had a rebuilt power supply board here. Now, as you remember in the first video, I basically just showed you what a stock SB200 looked like. And then in the next video, I showed you all the stuff that I ripped out that had to go. And then we were going to build back because we had a lot of circuitry changes we had to make. Now, as you notice back here, you know, we had all this. This thing was over here like this, as if you remember. That's all gone now. And this is all that's back here now, is the grounded grids. Use a piece of braid to ground the grid directly to the chassis. So it's pretty clear back here. We didn't do anything to the input circuit. That stays the same. But we will be going back and we'll be checking the input tune to see if that changes any now that we change the grid ground. And we may have to make some slight adjustments to the coils here. So not much up on the top except for, if you could see down in there, right over here, we lifted up the 1 ohm plate shunt resistor. We lifted it up and made a little TP type thing here with the 1.5 ohm grid shunt resistor. And here's our B minus over here. Okay, I'll flip it over. Okay, here we are on the underside. You recall we removed the SWR, removed the original relay double pole, double throw. We removed the soft key, which was for negative keying. And of course, the ALC and the grid resistors on that board, all gone. And here we are with the new build. Now what we did here is we have a three pole double throw switch. Typical 3-pole double throw switch that you would see like in an SB220. We have a third pole, which we used here. Here's our bias, self-biasing resistor here. Here's a 3-volt Zener diode right here. This white wire here is our B minus. Red wire down here is the positive of the relay coil. Over here, this yellow wire is the negative side of the coil, which goes over here. This is a soft key for positive keying. This would be the same one that you would use in an SB220. We rebuilt the power supply over here, the 120 volt power supply. In the SB200, it was using 120 volts negative. And we rebuilt it, and now we have 120 volts positive to run the relay and to run the soft key. We want one stump further here. We put a potentiometer for the sensitivity for the relative power, and we put a potentiometer that had a switch on it. So this is now a standby switch here. So now we have a standby switch as well. We had to do a lot of work here on the meter switch. A lot of work done here. Had to change all the wiring of this switch. That's a little bit complicated. I'm not going to go into that. But we had to change that around so that we read our grid current and our plate current and the relative power. We no longer have the SWR meter. I mean, the SWR bridge, you could see we took it out there. That used to go along here. And now we just have a piece of RG58 going over here to the output of the to the relay. And of course, here's the RF over here coming out of the tank circuit here. And that comes over to the relay over here. So if you recall, if you want to go back and look at the previous video, you'll see how I cleaned up everything in here, stripped everything out, and started fresh on the new rebuild for the grounded grids. Here, remember I told you that I was going to reinstate the relative power? Here's the little relative power RF sniffer circuit right here, which goes through a resistor here and over to the SO239. So we sample a little bit of the output, we rectify it over here, and send it over to the potentiometer for sensitivity, and then over to the meter switch over there. So that pretty much covers what we did. The last video that I'm going to do on this series is going to be a performance video. We'll bring it over onto the test bench with the watt meter and everything, and we will see what kind of performance we get with grounded grids. And that'll be coming up maybe for tomorrow or the next day. I don't know, whenever I get a chance to do that. But for right now, this is the finished product, how we rebuilt everything here to accommodate the grounded grids and the three-pole double throw relay, because now we're doing the bias switching on the antenna relay. So that's it until we do the last one. 7-3 for now, W1QJ. Okay, folks, thanks for watching. Here we are. We're beginning out on 80 meters. This is the first band. For the performance test, we're going to go right through each band, 80 all the way through 10. Going to do each one. Once again, we're loading it up to almost up to or up to the full grid current. These are maximum performance tests. In this case, we're on 80 meters. The grid current is about 3/4 to maybe 7/8 scale, but not all the way to the end. I didn't bring it all the way to the end. In fact, I have a tiny bit of reflect, so I really couldn't get much more, but it's obviously more than enough. So here we are on 80 meters, 3.8. I'll show you my PEP input. This is PEP input. Hello test, hello test. Hello test, hello test, hello test, hello test. Hello test, hello test. So we're doing about average 85, maybe 90 with occasional peaks just above that, but less than 100 watts of drive. And like I said, we are in the safe limit of the grid. And if you want to see, I'll show you. I'll put out a carrier and you could see that it's put in an operate. You could see where the grid is. Well in the safe area. So we will go to lower sideband here. Here we're on lower sideband. You saw the input power between 85 and 90 watts PEP input. Once again, the grid current is in the safe zone. Hello test, hello test. Hello test, hello test, hello test. Hello test, test, hello test, hello test, test, hello test. Test, hello test, hello test, test, hello test. 1, 2, 3. Test 1, 2, 3. Test 1, 2, 3. Hello 1, 2, 3. Test 1, 2, 3. Hello test 1, 2, 3. There you have it. Well over 950 watts, and we're still in the grid. Here's the tubes. Just slightly warm. No problem. Look, folks, this is what happens when you convey the most power to the load. The tank circuit and the tubes just loaf. It's when you have mismatches that you have lots of losses. And here we have very little losses. And we have grounded the grids direct to the chassis. That's all we've done. Other than putting in a power supply and tweaking up the inputs a little bit. We didn't go crazy on it, but they're pretty good. So this is the beginning of the performance test, 80 meters. Once again, hello test, hello test. Test, hello test, hello test, hello test. Over 900 watts PEP. We'll be moving to 40 meters and all the way down to 10 meters. Thank you for watching. Okay, folks, we're back again. Now we're on 40 meters. This is the 40 meter performance test. Once again, loaded this up this time to about 7/8 of the full grid current. I didn't go any more than that, but I could have gone a little bit more, but I didn't. I could have. But I think it's good enough to give you an idea. You could actually run it like this, no problem, on sideband. Shouldn't have a problem working DX or whatever. I do recommend, however, that you don't run too much processing. But if you need that little extra when you're going after a DX station here, you know you got the sauce. It's there if you need it. Okay, so here we are. 7.2. We're loaded up to about 7/8 of the maximum grid current. And let's see, I'll put it in standby. Let's see what that relates to for PEP. Driving power. Hello. Hello test, hello test, hello test. Hello test, hello test, hello test. Hello test, hello test. Okay, so we were able to do almost 80 watts input. Now, if you look in the manual says this amplifier could take up to 100 watts of power, drive power. Look it up. It's in there on the first page under specifications. But here we're doing about between 75 and 81 watts PEP input. This is 40 meters, 7.2. I'll put it in operate. I just pull that out. Now let's go over here and see what we got. Hello test, hello test. Test, hello test, hello test, test, hello test. Test, hello test. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Hello test. Test, hello test. Over 950 watts output. Once again, 7/8 of the grid. 7.2, 40 meters. 950 watts output with around 80 watts PEP input. Once again, you don't have to run it like that, but you could see if you ran it here on 40 meters at 800 watts PEP, thing is just loafing. These are maximum performance figures. So that's 40 meters. Thanks for watching. We'll be back with more. Okay, folks, back again. Now we're on 20 meters. This is the 20 meter performance test. And once again, I've loaded the amp. In this case, on 20 meters, I didn't even bring it up to the full grid current. It's probably maybe 7/8 of the way up, but I didn't bring it all the way because it was getting kind of scary. But like I say, it's still in the white area. Okay, we'll put this over on PEP over here. And we'll see what the PEP input is. This is on 20 meters. We're on 14.2. Hello, test. Oh, wait a minute. Hello, test, hello, test. Hello, test, hello, test, hello, test. About 75, 76 watts PEP going in. Once again, we're in the white area on the grid. Okay, 20 meters. Here we go. Check it out. Hello test, hello test. Test, hello test, hello test. Test, hello test, hello test. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Hello test. Test, hello test. 20 meters. Over 900 watts PEP on 20 meters. Now you know why I didn't go to the full amount on the grid. I thought that was good enough. But I could still go more, probably bring it up to a kilowatt. And here's the tubes. No color at all. And it's just slightly warm up there. Hello test, hello test. Test, hello test, hello test. Test, hello test. Okay, that's 20 meters. And we'll be back for some more till we get to 10 meters. Thanks for watching. Okay, back again, folks. This is the 15-meter performance test. The 15-meter performance test. Here we are on 21,330 in the middle of the 15-meter sideband. Once again, I'll remind you that I've loaded the amplifier up to the maximum safe grid current. As long as it's in that white area here, you're safe. And I brought it up to that point, which means you can run this much power and the grids will be fine because it's in the white area. Once again, you may want to back it off a little bit, but this is strictly a performance test to see what this thing could do. And so here we go. It's all loaded up, ready to go. Like I said, to the maximum grid current point, still being in the safe zone. And that amount of power, let me put this in PEP here. Hello test, hello test, hello test. Hello test, hello test, hello test, hello test. Hello test, hello test, hello test. Test, hello test. Okay, PEP input is approximately 65 watts, give or take a little bit. So that's what we're putting in. I'll put it in operate, and let's go see what we got now on 15 meters. Hello test, hello test, hello test. Test, hello test, hello test. Test, hello test, hello test. Hello test, test, hello test, hello test. Test, hello test. Well, you can see we have over 800 watts on 15 meters PEP. And that's what about 65 watts a drive, over 800 watts PEP output. So that's the 15 meter test. Thanks for watching. Okay, folks, here we are on 10 meters for the 10 meter performance. Now, just to save time, I want to let you know, once again, that I've loaded the amplifier up to the maximum grid current, which means this would be the maximum that you'd want to go with this amp and still be in the safe zone of the grid. Now, you may not want to run it this way, you know, regularly, but just to give you an idea of what it can do, you're still going to be in the safe zone of the grid. So here we are. We're loaded up on 10 meters with the amount of drive that gives us the maximum amount of grid current without going over. So here we go. I'll show you what kind of input power that is. Okay, we're on upper sideband. Let me do the input. Hello test, hello. Let me put peak envelope power here. Hello test, hello test, hello test. Hello test, hello test. Test, hello test. About 70 watts. Hello test, hello test, hello test. About 70 watts. Okay, now I'll engage the amplifier and see what it does on, this is 10 meters. Okay, here we go. Hello test, hello test, hello test. Test, hello test, hello test. Test, hello test. Test, hello test, hello test, hello test. Test, hello test. Test, hello test, hello test. So there you have it. We got about, go up as high as 850 watts PEP on 10 meters. So obviously, this thing will just coast at 700 watts PEP output on sideband on 10 meters. On 10 meters. So that's the 10 meter report, and that's the end of it. 10 meters is the last band. Thank you very much for watching.